Now, this video is intended to help you take all of the physics topics that we have talked about so far and kind of figure out a strategy, a way to combine all of those to solve some difficult problems. Because the truth is, when you get to some of that higher level physics, it's not about doing so many problems that you know exactly how to do it. Is how can we develop a strategy in our head so that when we're faced with something we've never seen before, how can we break that down into little steps and combine it so that it makes sense to us? Now, with that open-ended nature of harder questions, there's a lot of different ways that we can actually solve these problems. Now, my way is the way that works, especially for me. Now, if there's another way that you figure out helps you out, or if you want to tweak these, absolutely feel free to do it. But these are some different ways that I've used to help people kind of form their mindset around how do we break this into smaller chunks to solve for problems. So I divide it up into 3 essential steps. The first one is for any big nasty problem, I'm going to split it up into events. So things like sliding, colliding, falling, launching, anything that feels like a separate entity, a separate thing, I'm going to call an event. Once we have that split into events, we're going to assign a physics topic to that event. So whether it's forces or motion or energy or momentum, that's going to help us frame the group of equations, the group of ideas that we can use. And then number 3 is moving towards your goal. So starting essentially towards the outside and moving towards the variable or the thing that you are looking for. So in this video, I'm going to show you an example problem and how I use my 3 steps to actually solve for that. So we have a problem here where we have a cart of 40 grams as being released from rest at the top of this hill. Notice we don't have any friction, so that's going to be a really big help for us. And it is going to slide down the incline. Cart B is going to be doing the same thing. It's going to start from rest, and it's going to slide down the incline as well. So as they roll towards each other, they're going to have a head-on inelastic collision in this part of the track, and we're told to neglect any friction or drag force. So our overall goal is to figure out the velocity of cart A after they collide. So let's take our strategy. Step number 1 is to split it up into events. So there's a few major things that I see happening in the problem. The first one is the slide. So cart A is starting from rest. It's going to glide down to the bottom of that incline. Now, to a certain extent, cart B is going to be doing the exact same thing, just from the opposite side. So same idea, just going the other way. So I might consider that a second event going on. So once these 2 carts get to that horizontal plane, they are going to collide together. So that's kind of our 3rd big event. So you notice by splitting up our big problem into little chunks, gives us more specific ideas of what we can use to actually solve for this problem. So number 1, split it into events. In our case, we have 2, essentially 3 events that we can use. Now, step number 2 is take those events that we have and assign a physics topic to them. And this kind of comes with a little bit of experience, some different questions that we've done before in each isolated topic. But I look at those slides, and we've done things like that before with inclined planes where there's different forces. We know that gravity is going straight down. With the angle, we have to break it up into components to figure out what part of gravity is in the y or the x direction, normal force, things like that. So we've dealt with that before. And we've dealt with distances, and we've dealt with speeds and things like that. But we've also dealt with it in terms of energy, where we have a certain height. We have energy being stored in different ways in different points in the slide itself. So we have 2 options that we can use, but I'm going to skip to the middle part for right now until we talk about which one we might want to pick. Inside collision, that should always mean momentum. Maybe we have some energy ideas that we want to deal with as well, but more often than not, when you have a collision, we're dealing with momentum. So now we need to make a decision. Collisions typically mean momentum, so we're kind of stuck with that guy. we need to decide if we're going to deal with forces or if we're going to deal with energy for those slides. Now, in my brain, I usually want to jump to the easiest thing. And because splitting things up into force components usually is not the easiest thing, sometimes I rely on energy because it's really, really handy and kind of doesn't depend on directions. But also, we don't really have the angles in there. It's going to be really hard to find our components. We don't really know the length at which they're traveling. We don't know the hypotenuse of each of those inclines. We don't know the base of those. We do know the height. So based on the information, I'm probably going to stick with energy just because we're lacking a lot of information for the forces and motion idea. So for the slides, I'm going to stick with energy. For the collision, I'm going to stick with momentum. So then number 3, we've kind of set up our problem to solve for. The third step is to start solving it out and move toward your goal. And again, if you like to start with the unknown and work your way out until you find those variables that we don't actually know, that is perfectly fine. That is totally up to you. So if you want to start with momentum, that collision, and work your way out, that's fine. But what I'm going to do is I'm going to start with the things on the outside, those 2 slides, and I'm going to work my way towards that collision because the odds are there's a lot of things about the collision that we don't know. So let's start that off. I'm going to start with cart A, and I am only going to focus on the first part of the problem where it is sliding. So we have energy being stored at the top of that ramp. It's going to slide down and get to that horizontal portion of the ramp. So I need to figure out how is energy being stored in each of those locations for this example. Now this is where it gets really specific to this problem on essentially what we're trying to solve for. So cart A at the very top, all of our energy is being stored as gravitational potential. We don't have any motion because we're told it's at rest. No spring potential. We're told there's no friction. We're going to deal with gravitational potential at that point. And at the bottom, we're saying at height 0, we don't have any height, so no gravitational potential. Still no springs. Still no friction. So we're gonna say that we are purely kinetic energy at the bottom of the incline. So that's going to help me construct my equation. So at the top, the initial part, I'm pure gravitational. At the end, I am pure kinetic energy. So from there, I'm going to break it down and I'm going to start plugging some numbers in there. So I know that gravitational potential is m times g times h. I know kinetic is 1/2 mv squared. And I'm just putting the a's to represent, I'm talking about cart A. So I have mgh equals 1/2 mv squared. And what's really nice about this equation that we've created is the masses are going to cancel out. Since we know that the mass is not changing between the beginning and the end, those essentially go away. So we're stuck with g times height is 1/2 v squared. So let's start plugging some numbers in there. So my gravitational field strength is 9.8. The height for cart A is 4 equals 1/2 v squared. And if we start solving for that, I'm going to multiply both sides by 2, which gives me 78.4 is v squared. And then my last step is to take the square root of that value. And we come up with plus or minus 8.85 meters per second. And that's really important because we'll deal with what that plus or minus might represent in the next part when we're dealing with the momentum stuff. So since we're trying to move towards our goal, probably the best idea next would be to kind of do the same thing for cart B, is to figure out what is the velocity of cart B before they hit down at the bottom. So take a second to figure out the velocity of cart B as it hits the incline. Okay, now that we have the information of the velocity of cart A and the velocity of cart B as they hit the horizontal portion of our problem, now we are in the zone of momentum. So we know we're going to have that collision, and we're definitely going to need that velocity information in order to solve the problem. So I'm going to break it down into collision. I'm going to completely ignore the inclines and just say, hey, I know that my initial velocity according to momentum for cart A is 8.85, and I know the velocity for cart B when it gets into that momentum zone is 6.26. So let's create our momentum equation. So we have the initial momentum of both of the objects right here. So mass of cart A times its velocity plus the mass of cart B times its velocity. I know, according to the conservation of momentum, those have to be equal to the final momentum after they collide together. So this is just the skeleton that we learned in our isolated momentum portion. And I am going to start plugging in some numbers. So I know the mass of cart A. The velocity of cart A, I need to make a choice. It either is 8.85 positive or a negative 8.85. So what I'm going to say is, since cart A is going to the right, I'm going to keep that velocity as positive. If we look at cart B, that has a mass of 80 kilograms, it's going to the left. So I'm going to assign its velocity as negative 6.26. And over on that right side, it's equal to 40 times the final velocity plus 80 times the final velocity. And I am looking for the final velocity of cart A. I don't know the final velocity of cart B, which is a problem. But if we look at the problem, we are told it's an inelastic collision, which means those two objects are going to stick together. And that gives us a really important piece of information, that velocity of A and velocity of B are going to be the exact same since they're stuck together. So I can just add those two together. 40 plus 80 is 100 times the final velocity really of both of those carts. And then it's a matter of plugging and chugging. So I'm going to multiply 40 and 8.85. I'm going to add it to 80 times negative 6.26. And then last but not least, I'm going to divide all of that by 120 to get negative 1.22 meters per second for my final velocity. And notice how that value is negative, which tells us that cart A is actually going to go backwards after that collision. And cart B is as well, because we are in an inelastic collision. So again, keep in mind that no two problems are going to be the same. So instead of doing a ton of problems and trying to memorize what each one might look like, think about the strategy. So step number 1 was we split that question into events. Step number 2 is we assigned a physics topic to each event. And step number 3 is to move towards your goal, in this case going from the outside to the inside. Now, of course, there's a lot of different ways to actually solve for these problems. So if there's another way that works better for you, absolutely go for it. But this is a nice little framework to help take some of those overwhelming problems and break them down into more simple steps.